All right, so now we're going to put it all together here. So we had from before, we've got our steps. So the first thing we're going to have to do is isolate the trig term. So if you look here, that cosine is not by itself. The problems that we were doing before, I gave you cosine by itself. So I'm going to have to do a little bit of algebra here. So the first thing I'm going to do is I'm going to add 1, and you don't have to show all these steps because I'm sure you can do a lot of this in your head. But you get radical 2 cosine theta is equal to 1. Then I'm going to divide both sides by radical 2, and I get cosine theta is equal to 1 over radical 2. But you can't have a radical at the bottom, plus 1 over radical 2 does not look like any of those numbers from my quadrant. So what I'm going to do now is I'm going to rationalize. I'm going to multiply the top and the bottom by radical 2. So I get cosine theta is actually equal to radical 2 over 2. All right. I didn't tell you which quadrant to draw it in like I did in those other problems. I said it's somewhere within a circle. So what you're going to have to figure out, first of all, cosine stands for our x value. I want my x value to be positive. So what I'm going to do is I'm going to graph, and I'm going to figure out in which quadrants would my x value be positive. So that would be over here on the right because x always goes to the right. And that was another reason why I went over this. So these two quadrants are where x would be positive. So I'm going to make half of that bow tie. And I know that my x value, this part of the triangle here, is radical 2 over 2. Now, if I were to make an ordered pair, I know the x value is radical 2 over 2, which means the y value also has to be radical 2 over 2. That's going to tell me that the reference angle is 45 degrees or pi over 4. So both of these reference angles are pi over 4. And it's kind of hard to label both of them, but since I've got two triangles, that means I'm going to get two answers for theta. The first one is this angle right there in the first quadrant, which is just the same as the reference angle. So one of my answers is theta is equal to pi over 4. My second angle, again, starts here, and I come almost a full circle. So remember, a full circle is 2 pi. Since I'm dealing with pi over 4 as a fraction, I'm going to change that 2 pi to 8 pi over 4, because 8 over 4 is 2. Notice this angle doesn't quite make it a full circle, so I'm going to have to subtract pi over 4. 8 pi over 4 minus pi over 4 is going to give me 7 pi over 4. So this is telling me for this problem, we just found that cosine would be radical 2 over 2 when the angle is pi over 4 or 7 pi over 4. All right, let's try another one. Okay, the next one, notice we have sine twice. So if you can combine like terms, think about algebra, I'm going to do that first. So I am going to subtract 3 sine theta, and that's going to give me 5 minus 3 is 2 sine theta, minus radical 3 is equal to 0. We're trying to get sine by itself, so we're just doing algebra. We're going to add radical 3 to both sides. So now I've got 2 sine theta is equal to radical 3. I added that to both sides. I didn't show the step like I did over here. Hopefully you guys are okay. Then I'm going to divide both sides by 2. So now I'm left with sine theta, I got my trig function by itself, is equal to radical 3 over 2. All right, that radical 3 over 2 should look familiar. That's one of our numbers from our first quadrant. So notice it's sine. Sine is my y value. So I want my y value to be radical 3 over 2. You should be able to look at this and get that right away. Here's the y value, radical 3 over 2. So that means we're going to have a pi over 3 or 60-degree angle. All right. Now, where would y values be positive? So y values are positive, y's go up. So I'm going to have a triangle here. That's where y would be positive. And right here, y would be positive in both those quadrants. Now, since the y value is radical 3 over 2, I already showed you from that first quadrant there. You could also do the hand thing if you like that. But radical 3 over 2 is going to give me an angle of pi over 3, a reference angle. So both of these reference angles are pi over 3. Now, right here is pi, half a circle. So I'm going to get two answers for this problem. The first one is just, if it's in the first quadrant, it's always whatever the reference angle is. So my first angle is just pi over 3. If it's first quadrant, it should be really easy. Now, this is going to not quite make it to pi, which I'm going to change that to 3 pi over 3 just because it's dealing with thirds here. So it's not going to quite make it there, so I would do 3 pi over 3 minus pi over 3, which is going to give me another angle of 2 pi over 3. All right, if for some reason I would have been down here in this quadrant and I would have gone past, I would have been at 4 pi over 3 because I would have gone 3 pi over 3 plus pi over 3. But we just have to see what makes our situation work. So like if this would have been negative radical 3 over 2, then my two triangles would have been down here. Over here, if this cosine would have been negative, then I would have had my triangles over to the left. So you really have to just use what you know about your x and your y values to help you with this. All right, next one, cotangent. All right, cotangent is one of those kind of weird ones. Also notice that it's squared. So let's go ahead and get cotangent by itself first. I'm going to first add 3 to both sides. So I've got cotangent squared theta equals 3. Remember how we get rid of a square? We square root. Don't forget, whenever you take a square root, you need to do plus or minus. So this problem, so far, I've got cotangent theta, we got rid of the square by taking the square root, equals plus or minus radical 3. All right, if you don't like cotangent, that's just the reciprocal of tangent. So you can very easily just kind of flip this. I feel like usually people are better with tangent. Tangent means sine over cosine or y over x. If you were okay with cotangent, you could have just said, okay, well, that's x over y. Just more to remember, but whatever works for you. What I'm going to do is I'm going to take this radical 3 over 1 and I'm going to flip it to make it be a tangent. So that would be 1 over radical 3, still plus or minus. Now, look at all of your ordered pairs. I need ordered pairs that are going to simplify to give me 1 over radical 3. Well, we can forget the radical 2 over 2, radical 2 over 2, because if I divided those by each other, it would give me 1. So it's going to be one of these two options. It's either going to be pi over 3 or pi over 6. I need my y value to be 1. So really up on top, I want 1/2. And at the bottom, I want radical 3 over 2. If I cross out those 2's, I get my 1 over radical 3. So I need my y value to be 1/2 and my x value to be radical 3 over 2. So take a look at this. Here's where my y value is 1/2. Here's where my x value is radical 3 over 2. That's going to be pi over 6 or 30 degrees. Now, since it was plus or minus, I'm okay with any answers that come out positive or negative. So whenever you have this, you're going to get the full bow tie. So we are going to get 4 different answers here. All right, so my y value was the 1/2, my x value is radical 3 over 2. We already determined that that's going to be a 30-degree angle or pi over 6. All of these reference angles are pi over 6, so I'm going to get 4 answers. My first one should be easy. It's just in the first quadrant. So my first answer, theta, is pi over 6. The second angle is going to come over to here. It's not going to quite make it to pi. Think about what I would change that to if I'm dealing with sixths. 6 over 6. It's not going to quite make it there. So what I'm really doing here is I'm doing 6 pi over 6 minus pi over 6, and that gives me an answer of 5 pi over 6. The next angle is going to go past 6 pi over 6. So this time I'm going to have to add pi over 6 to that. So 6 plus 1 6 gives me 7 pi over 6. And then this last one is almost going to make a full circle, but not quite. Remember, a full circle is 2 pi. Since we're dealing with 6, I would change that to 12 over 6. And it's not going to quite make it there, so it's 12 pi over 6 minus pi over 6 gives me 11 pi over 6. So I got 4 answers on that one. All right, I know this is a lot, so we're splitting this up over a couple days. We've got 3 more examples to go. We can do this.